In this class, what we are going to learn is about an recursive descent parsing. And right, as I already explained, what the concept of recursive descent parsing is by giving the definition, by making you to understand by knowing what the definition of recursive descent parsing is, and also I gave some examples how uh, the backtracking involves in recursive descent parsing. And again, I'm repeating the same most important points, starting with the definition of recursive descent parser and showing with an example how the backtracking involves in the recursive descent parsing, and then I will explain how to write the program, in an recursive procedures in recursive descent parsing, right? And here, what is the definition of a recursive parsing, recursive descent parsing, or we can also call it as a recursive descent parsing or RDP. RDP is nothing but a recursive descent parsing. In top-down parser, we are having two types of techniques. One is recursive descent parsing. The another technique is a non-recursive descent parsing. As we all know, because we already learned in the last class and we understand how many techniques that the top-down parsing consisting of, and in recursive descent parsing, what the problem is, here we're having the problem with the backtracking. Why? Because the backtracking involves in recursive descent parsing. We are considering that is the major issue, that is the crucial issue for implementing the top-down parser. So we are going for the other techniques. We are going for implementing the other techniques like an predictive parsing. The predictive parsing can also be called as a non-recursive descent parsing, or it can also be called as an LL of one parser. Right. In the last classes, I already explained all the steps that are followed when constructing the predictive parsers. Right. And here in this class, what I am going to explain is I'm making you to understand how to write and program, how to write the procedures from the given grammar in a recursive descent parsing, right? And what the definition of recursive descent parsing is. Here, the parser, recursive descent parsing is one type of an parser, right? And this parser uses collection of recursive procedures for parsing the given input string. That is nothing but a recursive descent parsing. Again, I'm repeating what the definition of recursive descent parsing is. Parser that uses collection of recursive procedures for parsing the given input string is called as a recursive descent parsing, and uses the collection of recursive procedures for parsing the input string. What the meaning of that is, for example, I need to parse an input string from the given grammar to show that the input string is the input string is an acceptable input string for the recursive descent parsing. What it means is, for such type of an grammars, by taking some input strings, we can generate an recursive procedures, right? We can generate an recursive procedures. How we can write the recursive procedures from the given grammar? That's the question here. How we can write the recursive procedures from the given grammar? And for that question, we're having an answer is, in this type of parsers, the context-free grammar is used to build, right? Because the specification that we are using in the form of an context-free grammars, and use it to build the recursive routines. And how we are building the recursive routines means, the RHS of the production rule is directly converted to an program. What it means is, taking an example, our production rule should be in the format of A tends to alpha, right? And here the A is on the LHS and alpha is on the RHS. What it means here is, what the alpha is, it is on the RHS side, means tends to, after whatever the rule we are having, we are writing the program for that RHS of the production rule. We are writing the program for that RHS of the production rule. What it means is, we are directly converting it into an program, right? And for each non-terminal in the sense, for example, all the left hand side of the variables in the given grammar should be the non-terminals. For each non-terminal, a separate procedure is written, and the body of the procedure, we can call it as a code. The body of the procedure, we can call it as a code, is RHS of the corresponding non-terminal, right? Is it clear now how to construct or how to write the recursive procedures? That means we are taking the production rules. We are taking the production rules from the given grammar, and we are writing the procedure for the LHS of the variable, and the body of the program is an RHS of the rule. The body of the program is an RHS of the production rule, right? Is it clear now? The definition of the recursive descent parser and in which specification we are taking, that means how we are parsing the input string and how the recursive routines are building out the recursive routines that we are building by using the context-free grammars, right? And how we are building these recursive routines, what the steps that we are following here, what the main important points that we are considering here, that the two important points are the LHS of the production and the RHS of the production. For the LHS of the production, we are writing the procedures, and the RHS becomes as an program, or we can also call it as a procedure code for that RHS of the production rule. For that RHS of the production rule. This is called as an recursive descent parsing. See here, as I already shared the slide to you all, once all of you see the slide, there we are having some important points. What those important points are, this recursive descent parsing is a top-down parsing method, right? We all know, because top-down parsing consisting of two types of techniques. In that, one type of a technique is a recursive descent parsing. And these procedures are always associated with each non-terminal. As for the left-hand side of the variables in the given grammar, we are writing the procedures, and these procedures are associated with the RHS of the production rules, right? And then what the next one? Always we are using the leftmost derivation. Why? Because here the implementation is an top-down approach implementation. So in top-down approach, it involves an leftmost. We apply the leftmost derivation here for an input string. For deriving or finding out an input string, we are using a leftmost derivation here. And here, what we are doing here is to construct the parse tree. To construct the parse tree for the input, starting from the root and creating the nodes of the parse tree in a pre-order. What it means is, what the definition that we all know about the top-down parser. That means starts from the root and ends with the leaves. Starting from the root and ending with the leaves. That's what we are implementing here. It is an attempt, but we are constructing in such a manner in a recursive descent parsing. And here see the last point where it is the most important point. And here this is one of the major problem that we are considering. And to overcome this problem, that's why we are learning the other technique like predictive parsing technique. We are learning the other technique like a predictive parsing technique. In that predictive parsing technique, that LL of one grammars does not involve the backtrackers. Does not involve the backtracking process. Right. See here, this is the major problem here. Make a note of this. What the problem from the recursive descent parsing? Why we are learning the other techniques means here we are having a problem. To eliminate this problem, is there any syntaxes or rules or any algorithms that we need to follow? Is there any syntaxes for the elimination of the backtracking? No syntax, and we're not having any algorithm to be followed. There is no step-by-step process to be followed for eliminating the backtracking. Then how to eliminate this backtracking? How to eliminate this backtracking? First, see the example here. Consider the grammar. This grammar is an backtrack. This where I'm explaining for the backtracking. Why? Because this recursive descent parsing involves the backtracking. So now I'm explaining what the backtracking is by showing with an example. Consider the grammar. See here we're having a grammar, or the grammar is S tends to CAD, A tends to AB or A. S is only having the one rule, A is having the two rules. The variables are S and A, and the input string that we need to generate is an W is a representation of the string, and here we need to generate an input string as in CAD. Right, make a note of this input string, note the given grammar, and now checking out whether the tree representation, when we are representing a tree and checking out whether the tree is consisting of any backtracking or not. And here we are constructing a parse tree for the given input string using a top-down approach. That means we should start with the label. We should start with the label itself. That means the starting symbol of the given grammar is an S. We all know these rules. So by following these rules in the top-down parsing, now see here we're having 3 steps process, 3 steps. That means here the representation of the parse tree we done in a 3-step process. Why? Starting with an S. S derives or defines CAD, right? What the input string that we need? CAD. CAD. And what A is having the 2 rules, right? And here in the place of A, at one time I use AB. In the place of A, at another time I use an A. But this C is the correct derivation tree. This third step is in correct derivation tree. The second step is not in correct derivation tree. Why? Because here we are generating CABD, starting with the root and ending with the leaves, but the leaves are the input string. The leaves are from the input string CABD. This is not the string required string that we need to generate. The required string is an CAD. What it means is here what we are doing after choosing the alternative of this A, after knowing that this is not the correct input string that we need to generate, then we're going for the next step, right? What it means is here again we are doing a loop. We are forming a loop. That means we are again entering into the variable A, and again we are choosing the another substitution, another alternative, then we are substituting here. What it means is here itself we are encouraging the backtrackings. That means here this involves this type of parsings involves the backtrack. And what is an backtracking? How to eliminate this backtracking? And this backtracking is nothing but a technique, is one of the technique in which here for expansion of the non-terminal symbol, we choose one alternative, and if some mismatch occurs, then we try another alternative if any. Then such type of process can be called as a backtracking process. That's what we done here. Here we done the same thing. Here for the expansion of the non-terminal A, we choose one alternative like an AB. And for the A, there in the grammar itself, we are having, from the given grammar, we are having 2 alternatives, right? And here mismatch occurs because we need to generate an input string CAD, but here we are generating an input string CABD. Mismatch occurs. Then what we are doing? Then we try another alternative. We're trying another alternative like this. So we need to eliminate this step number 2, and directly from step number 1, we need to represent this step number 3. That's the process of eliminating the backtracking. That's the process of eliminating the backtrack. What it means is, if for any non-terminal, there are multiple production rules. See here for the A, we're having multiple production rules. But for the S, there is only one rule. Beginning with the same input symbol, then to get the correct derivation, we need to try all these alternatives. And here, what will happen if you perform like that means, in backtracking, we need to move some levels upward in order to check the possibilities. See, because for checking of the possibilities, where I'm going, I'm moving upward. That means I'm going to the variable A, moving to the variable A. What it means is, if I done like this, if I do the process like this, by encouraging the backtracking, what will happen means, this increases a lot of overhead in implementation of the parsings, right? Make a note of this. Increases lot of overhead in implementation of the parsing, and it becomes necessary to eliminate the backtracking by modifying the grammar. How to eliminate, how to modify? Is there any syntax or rules for modifying the given grammar? There is no syntax or there is no algorithm for modifying the given grammar. It's just a human common sense. At the starting of the given grammar itself, when we saw what the input that we need to generate, just see here CAD. Just by choosing an alternative, instead of this, directly we can choose A tends to A, then we can eliminate and backtracking. That is that is the expansion of A, chooses the correct terminal, correct rule without any mismatch, correct rule without any mismatch. Make a note of this, right? And here it's just an human common sense. How to eliminate the backtracking is, it is one of the technique, but here there are no rules to be followed from any type of an algorithm. So it's just an common sense to eliminate such type of moving upward process. So then we can eliminate the backtracking, right? Is it clear? Now, writing and program for the recursive descent parsing. That means here a collection of recursive procedures are written. See, in the given question, in the given grammar, we are having S and A. S and A are on the left hand side of the given grammar. That means left hand side of the production rules. And for the S, the right hand side of the rule is CAD. For the A, the right hand side of the rule is AB or A. Right? Just first initially get clear what the left hand side variables and what the right hand side variables. Right hand side, for the right hand side production rule, we are writing the procedure code. Just by calling the procedure for the left hand side variable. Just by calling the procedure for the left hand side variable, we are writing the procedure code for the right hand side. Make a note. And how we are writing this? Is there any steps to be followed for constructing the recursive descent parsers? Is there any points to be followed here? Yes, we're having some most important points to be followed. Based on those, we are constructing the recursive descent parsers. And that means points in the sense we're having some steps to be followed. Step number one, totally what the steps considered based on the input symbol, Make a note of this step number one. If the input symbol is non-terminal, that means capital S or capital A, if the input symbol is non-terminal, then a call to the procedure corresponding to the non-terminal is made. That means like this. A, you need to write like this. A, it is in the next step, we need to write the procedure for the A. So we are denoting like this for the A. That means what the indication of that is, it is a non-terminal. Then a call to the procedure corresponding to the non-terminal is to be made. In the next step, we are writing the procedure for the A. So we are representing like this, right? If the input symbol is in terminal, see here, what the input symbol is terminal, C is in terminal, right? Then what to do? Then there is a match occurs. Just when we are writing this one, when we are writing the procedures, recursive procedures, just write down here what the input string you need to generate. That is CAD, right? Write down in the buffer. That means the C should be in one cell, A in one cell, and D in one cell. At the C, under the C, just make an arrow representation. That what it means, it is a look ahead pointer. If the input symbol is an terminal, what to do? Move advance, then begin move advance. See, move advance the look ahead pointer, right? And then if the input symbol is an non-terminal, then you need to write like this. If the input symbol is an terminal, then again move advance, begin advance. And for every variable here with the CAD, the right hand side of the production rule is completed for the S. By reading the CAD with a look ahead pointer, the right hand side production was completed for the S variable, right? Now we need to go for the second rule, that is an A tends to. So to end this rule, what we need to write there is return true and return false end. At each and every production, we need to define like this: return true end, return false end, right? That means here we complete the procedure for only the variable S. Now we are writing the procedure for A. See here, procedure A, begin. What the input symbol is? A, right? Then begin and advance, move advance. That means match occurs, then you should move advance. If the input symbol is B, then begin, move advance. See the difference between when we are reading an input symbol with the terminals and when we are reading an input symbol with an variable. If you read an input symbol with an variable, after C from the given grammar we are having an A, right? Means here we are having the look ahead pointer. Now this pointer reading an A. Then in the program, in the code itself, how we are defining that if A method. A method means this is the procedure that we need to make in the next steps. This is, we need to made in the, that means we need to call a procedure in the corresponding to the non-terminal in the next step. We need to made, it was not completed. The variable for the A is not completed. Now we are writing for the procedure only for the S, right? So that's the different. If the input symbol is a terminal, if the input symbol is a non-terminal, means if the input symbol is a non-terminal, you need to write down like this. Then what the input symbol is terminal, then move advance, begin advance, like that. And here in the A, right, B, then begin advance. And for the rule A, we're having two rules. For the production, for the variable A, we're having two rules. A tends to AB, A tends to A. Here the A tends to AB was completed. AB rule was completed. That means after reading the B, and if the begin, then begin moves to advance, then what we need to define there means return true, end, return false. Return true, end, return false. Then here we need to make a comment that if it is failure to find the AB, if it is failure to find AB, AB means for the A we are having two rules, AB, then input symbol is equal to A, means A is having the two rules, AB or A. For AB we write the code like this. Now we are writing for the A. If the input symbol is A, then begin advance, return true, return false, end. Return true, end, return false, and these are the common lines. These are the common lines that we need to represent in each and every procedure itself. In the procedure, by procedure for the variables, for the non-terminals, we need to define all this, right? And now the overall grammar was completed. Here I am having only the two rules for the given grammar. That means two variables for the given grammar. Nothing is there. The grammar is completed. Then finally success. Then finally success. When we are terminating this, means when we reach an dollar symbol, when the look ahead pointer, when a look ahead pointer points to the dollar symbol, because when we are storing in the input in an input buffer, at the last we need to make an dollar symbol. In the last class at the stack implementation, I show you that. I show you all how to represent the input string in an input buffer. When the look ahead pointer reaches the dollar, then what it means is end of the buffer, end of the buffer. That means the input string was consumed. The input string was consumed. What it means is now we can quit by reporting success, and finally success. Finally here we need to represent like, write down like success, right? Is it clear now? Thus, and what it means is, therefore the input string can be parsed using the recursive descent parsing, using the recursive descent parsing. Here we're having one of the advantage by implementing this type of recursive descent parsing is the recursive descent parsers is easy to construct, and here what the problem we're having with this is, and also along with the, when it is very simple and easy to construct, and the programming languages we can choose for recursive descent parsers should support the recursions also. And here we need not to bother about what the internal details that are accessible in this type of parsers. So what it means is the internal details are not accessible in this type of parsers, and we cannot access the current leftmost sententional forms. So these can be taken as an problems in the recursive descent parsers. And the next thing is we cannot access the stack containing the recursive calls. So this is also one of the problem. So, and here for writing the procedures for the left factorial, see what the syntax of the left factorial, A tends to alpha beta 1, alpha beta 2, so on, like or so on, right? And if we are having the grammar like that, if you are having the grammar consisting of the left factorial, then it is very crucial to write the recursive procedures for such type of an grammars. So what we need to do is, so to make such production simpler, first we need to eliminate the left factorial and then take the modified grammar. For the modified grammar, we can write the recursive procedures. We can construct the recursive procedures. And here the most important point, make a note of this, in writing the recursive procedures or recursive parsers for all types of context-free grammars are, so again I'm repeating, we can't write for all types of context-free grammars. We can't write the recursive descent parsings for all types of context-free grammars. Make a note of this. For some type of grammars only, we can write the recursive procedures. That means we can implement the recursive descent parsings. So taking these as an problems in this, the most important problem in recursive descent parsing is it involves the backtracking. So to overcome that, we are learning the another parsing technique, that is a predictive parsing technique. And here what the advantages and what the limitations of the recursive descent parsings are. What the advantages and what the limitations of recursive descent parsings are. Make a note of this. One, the most advantage is these are very simple to build. These types of parsing techniques are very simple to build. And here these recursive descent parsers can be constructed with the help of the parse trees. With the help of the parse trees, we can construct this RDP. And what the drawbacks or what the limitations of the recursive descent parsing is, and parsers are not very efficient as compared to other parsing techniques. Make a note of this. We always trying to get our output, whatever the output we are generating, it should be in an efficient output. It should be in an efficient manner, right? Right. That is the main goal of the process of compilation. Whatever the target code that we are generating, it should be an efficient target code, right? So if we use this type of parsing techniques, these are not very efficient as compared to the other parsing techniques. And here there are some chances that the program for recursive descent parsers may enter into an infinite loop for some inputs. If the length of the input string is very long, if my length of the input string is very long for such type of the input strings, and there may be chances to enter into an infinite loop. And here we can't provide a good error messaging by using these types of techniques. And if you implement these types of technique, and it is difficult to parse the string, if a look ahead symbol is arbitrarily long. These are the drawbacks, or we can call them as the limitations of the recursive descent parsings. We are having only two most important advantages for implementing this type of parsings. One is simple to build. And the second one is these types of parsers can be constructed with the help of parse trees. These two are the advantages here. But the remaining, whatever I explained, all those considered as limitations or drawbacks or disadvantages. So for implementing such type of parsing technique like recursive descent parsing, we're having most of the reasons are the drawbacks here. Most of the reasons, just we're having two advantages, and more than two are having the drawbacks when we consider the recursive descent parser. So for such reasons, considering such reasons, so we are moving to the next parsing technique, that is a predictive parsing technique, right? Is it clear, all of you? And the construction of the predictive parsing technique by following the 6 steps was already explained to you all, and with an examples. And I already show how the stack implementation was done by using the parsing table, and how the parse tree at last, by using the syntax analysis, what we are going to generate the parse tree structure, right? We are generating the parse tree. So that's the output I already showed after implementing the first and follow function, and then first and follow table, and then constructing the predictive parsing table. By using the predictive parsing table, I already explained with the stack implementation, just by taking an input string and by parsing that input string by using the parsing table, we show that the given input string is an acceptable input string for the given grammar. And finally, I show the parse tree structure, right? That predictive parsing is an error free from backtracking process, right? So with this concept, the top down parsing technique is completed. And here the syntax analysis concept was not completed. Only the top down parsing techniques are completed, right? But why means here the parsing techniques are of two types. One is an top down, another one is an bottom up. From last classes to till the class, I explained only about the techniques that are involved in a top down parsing. From the next class onwards, I'm explaining about the bottom up parsing, where it is the second parsing technique in the syntax analyzer, right? That is the second parsing technique in syntax analyzer. After knowing the techniques in bottom up parsing, after learning how the constructions are to be done, by learning new techniques in bottom up parsing, then the total syntax analyzer will be completed, right? Still the half of the portion was remain. Half of the portion, that means implementation of bottom up parsing, is remain. So the first half is completed, and with this concept, as per our syllabus, unit 1 and unit 2 was completed, and on Monday onwards we are entering into the unit 3 by starting with the bottom up parsings, right? What techniques, in whatever the techniques that we are implementing in and bottom up parsings, one by one, that we are going to learn in each and every class.